Axial flux motors have become one of the hottest topics in the automotive world. Some models reportedly produce up to 300 horsepower while weighing only around 12 kilograms, leading many people to call them the future of electric motors. But are they really as revolutionary as the headlines suggest? Let's separate the engineering facts from the marketing hype. Despite the recent attention, axial flux motors are not a new invention. The concept has existed for nearly 200 years. What has changed is that modern manufacturing technology has finally made them practical to build. To understand the difference, compare them with a conventional electric motor. Most electric motors today use a radial flux design. They are cylindrical, with the rotor spinning inside the stator and the magnetic field flows outward from the center. An axial flux motor is completely different. It has a flat, disc-shaped design. The stator sits in the middle, while one or two permanent magnet rotors are mounted on either side. Instead of flowing outward, the magnetic field travels along the motor's axis. This layout offers two major advantages. First, the larger operating radius allows the motor to generate more torque. Second, the flat design makes it extremely compact while delivering impressive power density. That's why axial flux motors attract so much attention in high-performance applications. So why aren't they used everywhere? The first challenge is manufacturing precision. Because the magnetic forces act at slight angles instead of perfectly straight, even tiny alignment errors can create vibration and instability at high speeds. To operate smoothly, the motor shaft must be exceptionally rigid and precisely manufactured. The rotor and stator must also be assembled with incredibly tight tolerances, often less than 0.1 millimeter. Until recently, producing components with this level of accuracy was simply too difficult and too expensive for mass production. Although today's manufacturing technology has improved significantly, production remains complex and costly. Early commercial axial flux motors were largely assembled by hand, making them far more expensive than conventional electric motors. The second, and perhaps biggest challenge, is heat management. High-performance electric motors generate enormous amounts of heat. Because an axial flux motor uses a very thin stator, there is less surface area available to remove that heat efficiently. As a result, the motor can overheat quickly during continuous heavy operation. This is why axial flux motors are most commonly found in high-performance hybrid supercars. Vehicles such as the Ferrari SF90, the Mercedes AMG GT 63 SE Performance, and some advanced performance models use them to deliver short bursts of extraordinary power. However, these bursts only last for a limited time before thermal management becomes a concern. For everyday electric vehicles that require continuous power over long distances, cooling remains a major engineering challenge. Recently, several domestically developed axial flux motors have attracted attention, representing an important achievement in advanced manufacturing. They demonstrate that precision engineering has made remarkable progress. However, this does not automatically mean axial flux motors are ready for widespread use in every vehicle. Until engineers develop more effective cooling solutions, axial flux motors will remain best suited for specialized, high-performance applications, rather than replacing conventional electric motors across the industry. What do you think? Could axial flux motors become the future of electric vehicles, or will thermal limitations continue to hold them back? If you enjoyed this engineering breakdown, don't forget to like this video, subscribe to the channel, and turn on the notification bell so you never miss our next technology and automotive deep